A very good morning to everyone. Hope everyone is safe and healthy. I'm B. Mahalakshmi, third year student of JPR Institute of Technology, Institution Mission. JPR Institute of Technology aspires to provide technical education in futuristic technology with a perspective of innovative, industrial, and social application for the betterment of humanity. Department Mission to foster contemporary skills in the field of electrical and electronic engineering with innovative skills and global understanding, national skill building for the progress of humankind. On behalf of JPR Institute of Technology and Department of EC and EEE, we are glad to invite you all for this event, 6-day faculty development program on emerging advancement of wireless communication and application of power electronic in smart grid system. Faculty Development Program intends to provide financial assistance to facilitate upgradation of knowledge, skill, and intends to provide opportunity for induction training to teachers employed in engineering and technology. Now I welcome Mr. A. Anthony Charles, Head of the Department EEE, JPR Institute of Technology, to deliver the inaugural address and introduction speech. Please, sir.
Good morning, sir. Good morning. Good morning, everyone. Dear colleagues, friends, and ladies and gentlemen, a warm word of welcome to everyone joined with us to welcome you for the Faculty Development Program on Emerging Advancement of Wireless Communication and Application of Power Electronics in Smart Grid. It is a glorious moment to extend my warm wishes to our Honorable Director, Sir Dr. N. Mary Wilson, and our Principal, Madam Dr. L. M. Merlin Livingston, and Dr. Kamachi, HOD EC Department, head of the Department, EC Department. I also have a very special person, Dr. Saranan, Sir, our Chief Guest. I welcome you, Sir, on behalf of management. I take this opportunity to welcome all EEE and EC department staff members and each and every participants. Once again, I welcome you all. Thank you.
Yeah, you are
Uh,
muted.
Mahal- uh, Mahalakshmi's voice is not audible. Yeah.
Okay.
You
Guest
can.
profile.
Yeah.
Dr. Saravanan B., currently serving as Associate Professor at VIT University, Belur. He pursued his BE Electrical and Electronic Engineering at RVS College of Engineering and Technology, Dindigul. He completed M.Tech in Power System and Power Electronic and IIT Madras and PhD at VIT University in the thesis named A Solution to Unit Commitment Problem Using Classical and Stochastic Approach. He has about 22 years of experience in teaching at various colleges around Tamil Nadu. He received TEQIP Fellowship for Post-Graduation Studies (MTech) from the Government of India. He has published nearly 38 journals and 15 papers presented at international conference and one paper presented at national conference. Dr. Saravanan has undergone many short-term training programs and faculty development programs. We are pleased to have you here with us, sir. Now, I request Dr. Saravanan, sir, to take over the session. Please, sir.
Yeah, thank you, Mahalakshmi, and thank you, Anthony, the head of the department, EEE, to invite me to handle this session, Faculty Development Program, as part of your 6 days FDP. With my pleasure, um, I'm going to discuss my knowledge, what I have learned in the past 20 years of my teaching and research experience. Okay.
Thank you.
So yeah, thank you. So today my topic, so visible the screen, sir. The full screen is visible.
No, sir. No.
No. Okay.
No, sir.
I think now it's visible.
Yes, sir. It is visible now, sir.
Yes. Yes.
Yes, sir.
So today, uh, So I think that many different multidisciplinary audience are there in this FTP from EC department, Triple E, any other department, sir? Both EC and Triple E only. Is that it, sir? Anthony, sir?
Please detect disconnected, sir. Wait.
College faculties are attending, sir. EC and Triple E main faculties are attending, and remaining our college faculties also attending this. We'll
Okay,
give
sir.
it.
Okay. See, why I'm asking this mean, see, the
Yes, sir.
smart grid, the title smart grid is a thing where we need multidisciplinary engineers. Okay, it is not only belongs to electrical, it's not only belongs to electronics, even computer science people also there is a scope to work in this smart grid environment. Okay. So here, the smart grid, a conceptual overview. So what we are going to discuss about this mean in this session, I'm going to discuss about the traditional grid and how the traditional grid, what are the issues which is related to our present grid or traditional grid, how to overcome that in a smart grid. Even after implementing the smart grid, is there any issues related to the smart grid? Okay, and then in a rural environment, because the title is in a smart grid in a rural development, rural environment we are thinking. So in a rural environment, how this smart grid is implemented, or otherwise we can say it is a microgrid. So this microgrid structure is only developed for the rural environment. It started growing from rural only. So then only it is applicable into a traditional grid, and nowadays we are saying it as a smart grid. Okay. So in between, if you have any query, you just stop me and then ask. Okay. Yeah. So in the traditional grid, everyone knew about it. If it is an electrical person, you know that what is the traditional grid, what are the various things which is present in a traditional grid. You can see here that the total traditional grid is a very old technology, a century old, we can say that, which consists of a centralized generation, transmission, and distribution. So nowadays, very recently only, we are categorizing this centralized generation into deregulated environment. What is a deregulated environment? Means we are decentralizing the transmission as transcos. Even if you take our TNEB, we have transcos, discos, and gencos. So all these three sectors we are divided, and among these gencos, we are encouraging the private parties to enter into the competition, and they can support their own generation. Even the consumer, that is why it's called as prosumers. If you want, you can consume it as a rooftop solar panel if you are having, or if you have excess generation, we can able to um, give it to the grid also. Okay, so that's why it is saying to be a decentralized environment. And in transmission also, the third parties are there. There is a concept called wheeling. I hope everyone knew about wheeling. uh, There, from one station to other station, if you want to transmit your power, if the transmission line corridor is available, for example, in south part of our country we have the windmill. So from there, if you want to transmit the voltage or transmit the power to the north or northeastern part of our country, nowadays all these grid are interconnected. Nowadays it's possible. Only thing is the transmission connection should be there. So the third party is the owner for the transmission line, and from that we can able to get it. Okay. So that is about the generation, transmission, and distribution sector. To not understand the thing clearly, you can see this diagram. So there is a generation, maybe it may be a conventional power plant, or it may be a renewable etc. Okay, so from there, there is a, this is particularly for a traditional grid. That's why only conventional power like thermal power generation, hydro stations, nuclear stations, together we can say it as a traditional generation. So from there, there is a transformer, power transformer, which is sitting in the station itself, which is a step-up transformer, which is the only transformer which is step-up in the power system. So then it is going to a transmission line. So anyone know how much is the maximum transmission line we have reached so far? How much the maximum voltage we have reached? So you might have heard about 110 kV line, 220, 400 kV line, 765, etc. So far we have reached 1200 kV. That's a maximum voltage we are having. So from there we have a substation. There we are stepping down the voltage and then distributed so to the various consumers. The consumers are once again said to be our LT consumers and HT consumers. So these things are the traditional words which I am saying. So problem with the current power grid. So what is the problem with the existing one, existing power system model? Why we need to switch over to the smart grid? Okay, not only in the grid, everywhere we are thinking, even your phone, your mobile phone, you can take. Earlier we have a normal phone, so nowadays we are using a smartphone. So everywhere that smart is added. Okay, even if you have an energy meter in your house, earlier we have an energy meter which is analog type, then that is replaced with a digital one. So and today it is smart meters are there. Okay, so how this smart meter is different from the remaining in the sense it is bi-directional communication. So no accessor will come there and then take your reading. You'll be reading every bi-monthly. Okay, so there are some sensors. If you transmit the signal, it will fetch the information about reading, about the energy consumption, and it will be calculated. Okay, so the problem with the traditional grid is the transmission line loss. Transmission line loss is not only that we are saying the just a minute, please. Is it audio? Everything is fine, sir. Shall I go ahead?
Yes, sir. It's fine,
Yeah.
sir.
Okay. Okay. Just only thing is I stopped my webcam. That's it. Yeah. So whenever in a discussion, we'll open that. So now screen is visible, ma?
Yes, sir.
Yeah.
Visible.
Okay. Okay. Yeah. Traditional grid here. See the problem with the current power grid, as I mentioned, it is 20%. 20% is the transmission line loss. We are saying it is a transmission line is 20% in the sense it is not only due to loss, due to theft also included in this transmission loss. So it has not kept pace with modern challenges. That means limited alternative power generation sources, the distributed generation. Distributed generation, the sense, suppose for example, there is a paper mill or a sugar mill, if it is available, there is a possibility, that is called as co-generation. There is a possibility of generating electricity, but that is not able to connect to the distributing station in a present grid. Okay, so no solution for conservative use of energy, then higher rate of blackouts and brownouts. So these are due to so many reasons. There may be due to short circuit issues and due to overloading. So because of all these things, there are something called blackouts and brownouts happen in the system. Okay, so I hope all of you know about what is blackouts and brownouts. Then poor control and management of distribution network. Okay, this is the main reason. See, our generation is good, our transmission lines are good. Okay, with regulation within plus or minus 5%. The main issue is with the distribution network only. So why? Because the distribution network, even our TNEB don't have the information about the location of the distribution transformer. So if that is the case, we think about it, how to fetch the data. Okay, so that's why to modernize this distribution and to incorporate to add the generation in the distribution side itself, it is very difficult in the present grid. Okay, so a condition that led to concept of smart grid. So what are the various needs? Why we are switching over to the towards the smart grid, or why we are thinking about smart grid in the sense limited resources and increasing power demands is that is if you compare the demand growth, the demand growth is enormous when compared to the generation growth. So if you want to go for a station, a generating station or a conventional power plant, we need to spend minimum 5, maximum 10 years to construct a thermal station. Even it is more for a hydro station. So you think about the capacity addition in the generation. Okay, so that's the reason that we have to think about a smaller wherever possibilities we have to go for generation. That is why the concept of distributed generation, micro generations. So all these words are coming to pictures. Okay, so it's increased the distributed generation. Even we are thinking about a solar rooftop where we can utilize and we can able to import to the grid. Okay, there is a meter called net meter which is present instead of your energy meter. We have a net meter where we can able to what are the amount of energy you consumed and how much you have sent back to the grid, that will be calculated. That meter is called net meter. Okay, so the sources, various DGs possibles are wind turbine, solar energies, fuel cells, combined heat and power. See, not only this, all form of renewable energy. So wherever possible. Nowadays, from the waste also we are thinking about it. Using PV, that is using this PV cells, that is fuel cells, solar energies, wind turbine. So these are the various places where we are using. Okay. So uncertainty in power generation from renewable generation sources. So this is the main issues when I go for if I depend only on teach. So that's why what we have to do is we have to depend on both your conventional grid as well as your distributed generation. Okay. So here the additional problems. What are the other problems incorporated in the sense aging of the distribution system? If you take our distribution systems, the insulators, the conductors, it may be erected some 50 years back or 60 years back. Okay. So now if you want to replace the complete setup, you see nowadays in the insulator part, the insulators are coming with nano material where we can able to reduce the weight. So wherever now what they are practicing is wherever there is a puncture, so there only they are replacing and then they are replacing that with a nano material, nano component for the insulation material where they light in weight so that we don't want to put more supports, etc. Okay, but complete replacement is not economical and not feasible also. Okay, so the centralized generation and transmission systems are already running on the edge. The meaning of that is, see, if you take a thermal station, okay, in a thermal station, the generator may be capacity is 220 megawatt. If you go and see the nameplate detail of that, it may be written that it is 220 megawatt. But what if you go and see what is the generation it is generating mean, it may generate only 160 or 170 megawatt of power. So the reason is, so because of aging, already see for each and every machine, each and every component, there are some limitation. So it may work for next 10 years, 20 years like that. So already everything is the edge. Your generation, your generator, your transmission line. Okay, even though you have designed the transmission line 10 years or 20 years back for 100 megawatt of transmission, now you can't able to go for more than 80%, etc. Maybe the insulators get weak. Okay, so that is the reason we are saying here the centralized generation and transmission systems are already running on the edges. So not only the generator, the transformers also. Okay, the main costliest thing in the entire power system is the transformer, the power transformer. Once the power transformer gets failed, we don't have any backup as a standby transformer because of its cost. Okay, suppose you have motor in your house, if something goes wrong, we can go for a standby motor because it is feasible, it is affordable. But in a generating station, the complete generation, maybe 7 units are generated, 7 into 220 megawatt. So the entire thing is fed back to one or two transformers. We don't want to keep a transformer which is stay standby. That's why. So adding more capacity to generation and transmission is not feasible. Okay, and the solution for this is adding generation and distribution at the distributed generation level. That's why they are saying it as distributed generation. So this is the solution for the above cases. The above problem may be rectified if you have a generation so that I don't want to depend on the centralized station. I don't want to depend on the transmission line and don't need to worry about the agings, etc. Okay, so the once if you go for that, still there are some issues in DG also. So what are the issues in the sense you can see this is the plot which we have taken while doing one project. So that's why we are showing here. Suppose if you have in a microgrid structure, if you have wind, solar, CHP, and you have some demand in the sense, you can see that the bottommost line, the red line is the solar generation. Okay, it will go to the peak around 12 noon and then come back. Okay, then the wind generation is there, that CHP generation is there, and the demand curve is also there. So if you add everything, it should, if you add all the possible generation, it should match with your demand curve or the load curve. Okay, but in renewable energy system, the main issue is with the uncertainty. Okay, not only in solar, not only in wind, where whichever the renewable energy you are going for. So there is an issue of uncertainty in power availability. So then bi-directional power flow. So that is possible in a smart grid. So you can utility to consumer and consumer to utility. That's why I'm saying it as a prosumer. The word which you are using in the microgrid structure is prosumers. So increased operational difficulty. See, if you keep on adding different sources, interconnecting these different types of sources is once again a complication. Like, see, your solar will deliver the power in DC. Your wind power is in terms of AC. In wind itself, there are different types of generators are there. which is having their own characteristics. So interconnecting these characteristics together and together with the demand, there are so many. That is a separate area of research. Okay, so that's why even with all these difficulties, we are thinking about the smart grid. So what is that smart grid? So far we have discussed the issues related to the traditional grid and what is the urge to go for the smart grid. So smart grid is an application of digital information technology to optimize electric power generation, delivery, and use. So in all the three part, we can able to use this smart grid. Okay. See, there is no difference when you are with your conventional grid. With that, there is a minor changes we are planning. Okay. So one thing is we are going to add in the distribution side. The distribution side, we are planning to add some generation. That is one thing. Then second one is I can able to fetch. Suppose from here itself I can able to find whether the particular circuit breaker is open or not. Using SCADA already it is there, sir. Then how it is different in the sense the SCADA. So all the improvement of these technologies, computer technologies only, or information technology only lead to this smart grid. Okay, so the SCADA, supervisory control and data acquisition systems are there. So that's why I'm saying that there is a big scope for electronics communication here, automatically, ECEs, computer science, IT people, everyone together we can able to work in the smart grid structures. So smart grid is an application of digital information technology which is optimize the power delivery and generation. Okay, and self-healing. See, we will see one by one. What is self-healing? Then consumer participation is possible. Resist attack, high quality of power, accommodate generation options. In that, they are in the distribution side. Okay. So why we are saying all these things in the sense nowadays, even though we are having power, we don't get quality power. What is the quality of power? Quality of power in the sense the voltage is should be within the limit. Okay, if I am saying the voltage regulation is plus or minus 5%, that should be within that voltage limit. That is the limit. Okay, and without harmonics. So all those things is called as high quality of power or power quality. We can say that. So we'll see the reason for each and everything. So optimize power delivery and generation. So advanced efficient power generation, low transmission and distribution loss. Okay, so this is the two things to do the generation addition. Okay, low transmission and distribution loss in the sense if you are connecting the generation generator or distributed generator with small level in the range of 5 megawatt, in a distribution side, the transmission, the TNT loss is getting minimized. Self-healing, this is important. So real-time awareness of the system, that is fast responding if there is a fault. Just now I said that if there's something goes wrong, the which circuit breaker get tripped and the history of the fault, everything within a second, immediately after the fault, we can able to find it. So sometime the grid itself will heal it and come back to the normal position. It restore it on its own if it is a minor fault. If major fault is recorded, then it give the alarm to the operator to take care of the attention of this particular transmission line or generations, etc. Okay. So consumer participations, consumer can monitor and control smart appliances to manage energy use and reduce the energy cost. Okay, we can able to monitor the device, we can able to control the device. Device means even lamps, fans, everything we can able to. That is otherwise called a smart home. We can say that. So we are talking about smart grid. If everything, if all your industries, your domestic loads are smart, automatically your grid is also going to be smart. So resist attack. So here, real-time monitoring of power grid is possible. Using PMUs or using these SCADA technologies, we can able to monitor all the voltage, power, etc. Identify and respond to man-made or natural disruption. Okay, so it may be a natural disruption. There may be a storm due to that the transmission line maybe two conductors get short circuited or it may be a man-made fault. So all those things can be avoided and identified as soon as possible. Isolated affected area and redirected the power flow, arranging damage, that means around damaged facilities. That is, wherever the fault occur in the system, if we are not only identification, we can able to isolate it and restore the power as soon as possible. In high quality of power. So to overcome the power quality issues, that means the reduce outages, power quality problems such as voltage deviation, frequency deviations, harmonics. So all those things using the compensator, we can able to rightly find the compensator, and then we can able to calculate. Okay. So the various drivers, what are the things which is concentrated in the smart grid area in the sense it is majorly classified into three zones: utility zone, consumer or customer zone, and government side. What are the things necessary actions they have to do? So utilities, loss reduction, peak load management. That means utilities means the generation company. They have to go for loss reduction. That's why they have to encourage distributed generation, more renewables, etc. Peak peak load management. What is this peak load management mean? So during the peak load, when the load that is maximum, there is otherwise called as maximum demand. So mostly during summer, okay, in late evening between 6 a.m. to 8 a.m., the our load curve will reach the peak. So during that time, how you are going to manage? How to management in the sense, suppose your load is increasing from 500 megawatt to 750 megawatt, remaining 250 megawatt additionally from which plant we are going to supply. That is called the peak load management. And that is not for continuous phase, only for a short duration we need that. Okay, so that is why it's called as peak load management. Okay. Then renewable integration. So this is the I said this is one more another research area where it belongs to the utilities, where how to integrate DC source with the AC source with a different potential, etc. And self-healing grid. So these are the things taken care by the utilities and customers. They have to access to power easily. They have to access. It should be reliable. Not only reliable, it should be at affordable cost. Quality should be within the limit, and when there is prosumer, producer plus consumer enablement is should be possible. Choices of power purchase. So these are the choices of power purchase mean, see sir, suppose if your mobile tariff is more, today suppose you are using Geo, if the price increases, I am looking for some other operators who is giving the best quality with best price. So the same thing happen maybe near future. Nowadays already there for the industries. They are buying their power with cheaper cost, even 1 rupee, less than 1 rupee from northeastern part to the south part of the industry. Okay, through bidding. Okay, already this happened for HT consumers. So shortly, maybe within a year or 2 years, we will be having there is a competition among the power suppliers also. Okay, that is about the customer's perspective, and government they have to keep the satisfied consumers. Reduction in emission is the huge issues going on right now. How to reduce the emission? So obviously we have to go for renewable energy only. Financially sound utilities, tariff neutral system. Tariff neutral means tariff simple system. We can say that the tariff should be simple. It should not be divided into so many heads. That's why. So the overview of smart grid, you can see here. The definition we have discussed, it's a vision for the future. Near future, we can say that a network of integrated microgrid that can be monitored and heal itself. That is important, sir. It has to monitor and it has to heal itself. So if we go for a grid to be smart, many components are required. And think about how it is operating. Is there any power back for that? Okay, and there is a misoperation also possible. So while designing this smart grid, we have to keep uh, huge attention over all the appliances. So smart appliances in the house, then only the smart grid is advantage. That means we can able to shut down or we can able to switch over the load whenever you need. That's why it's called as smart appliances. What is smart appliances mean? Shortly for understanding purpose, I'll let you know. See, whenever suppose your washing machine is there in your house, it is not mandatory that you want to switch on the washing machine during your afternoon time, where the lower the tariff is uh, high. See, what is tariff in the sense? Our tariff is same, sir. That's why we are not aware about it. So whatever the time you are using your AC, your refrigerator, your tariff is going to be based on the energy consumption by monthly only. Okay, but once if these power there is private sectors are coming into the distribution system, then they will be saying that during late hours, if you are using your appliances, you have to pay only 1 rupee or less than 1 rupee like that. Okay, so based on the time if they are shifting, then in that case we have to see, maybe I can give a setting to the washing machine saying that to switch on at 10 p.m. or early morning 4 a.m. like that we can able to give wherever the tariff is less. Okay. Then demand management, that is otherwise called demand side management or demand response management. Okay, you can able to shift your work. That's right, to save the money instead of operating at peak time. As I mentioned, one example for your washing machine, it's not only for a domestic purpose, even for industrial load also. Night shift during night time if they are operating mean they see some if it is a thermal station, they have to give at least the minimum load should be operated. They can't able to shut down and suppose if it is a wind power plant, if there is no load, I can able to switch off the wind power and we can able to switch on it. Even if it is a hydro station, we can switch off for 15 minutes to half an hour of time, and then we can within a 15 minutes of time we can able to switch on. But for a thermal station, it's not possible. Okay, there is something called the uptime and downtimes are there, where you have to switch on if you want to switch on from the normal water to a higher temperature. Normally, the temperature of the steam is in the range of 540 degrees centigrade in our national thermal power corporations. So in that case, what happens means if you want to increase your stream from normal water level to that, okay, it take minimum 8 hours. So that's why it is not economical to switch off the conventional power plant like thermal station, nuclear stations, etc. Okay. Then we need some um, sensors to sense all the voltage. Your PME is also one type of sensors. Okay. Then to store all the information, we need to have a storage. Okay, to process means something goes wrong. So within a time, suppose in the past history, if suppose the particular transmission line is getting outage means it's getting tripped. In the past history, how we have recovered, if the theory is there, if the record is there, immediately we can able to check it. A new operator will come there. Okay, maybe 2 years back the same thing happened. So now what are the things they have done to recover the power as soon as possible? So you can go through that. That's why the processor is required. Okay, generators like small generators, solar panel, okay, distributed generation should be coming in. Okay, not only this, we can't able to depend only on these areas. We have to go for central power plant also. So there should be a grid connection. Okay, so these things are there in a smart grid environment. So if you see that there may be some disturbance happen in the grid. So how we are going to make it, or if there are some microgrids, you can see that this is the place where many generators as well as your central power plant is connected, and there is a small area, maybe 1 to 5 kilowatt of generation. Maybe some 10 houses are there in a street where everyone is having rooftop generation. In that case, that is called as a microgrid, and that should be isolated from this market whenever it is required. Okay, which should be isolated. There is your blackouts and brownouts. So the concept behind the smart grid are there are two different areas we can say that the operational technology and information technology. The operation technology, in the sense, all our things which we have discussed so far, like all technical aspects necessary for operation of network, substation automation, metering means smart metering. So all these things are required for operational technology. In the information technology, in the sense, the main thing we required in a smart grid environment is about the communication. So how fast you are communicating, how correctly you are communicating between the generator to the load and the central control unit. Okay, ERP, then building top level view, okay, what is the criticality level, office related reports. Just now we have discussed everything. So for all these things, for storing, retrieving the data and taking the necessary actions, we need to have these type of technologies. Okay. So here the concept of generation and demand balance. See, in a thermal power station or in a conventional power plant, we have generation in one side, we have consumption the other side. There is a load dispatch center. They will be looking after all the generations and load. What happens if the load increases suddenly? Suppose assume that all your generators is already generating the full level. Your load is also same, so everything is operating at the edge. Suddenly, due to some reason, if your load increased, then what we can do? How do you know that? In what way we can able to find it? The only electrical parameter which we are going to monitor is your frequency. So by knowing the frequency, we can able to find the uh, generation load what to say, difference. The difference between the generation to the consumption difference we can able to find it. Okay. So always ensure that the balanced generation and consumption means load. If it is balanced, then your frequency is within the limit. Even there is a small variation in the frequency is allowable. It should be within plus or minus zero point 0.5 hertz. Okay. Earlier it was 1.5 hertz. Nowadays the frequency change should be within plus or minus zero point 0.5 hertz. So it is very tight. Once if you are going beyond that, you will be sent off from the grid. So what is the problem, sir? If they come, then once again I can synchronize and then I can connect to the grid. Even 10 minutes of loss in the grid will lead to more losses. You can't able to supply your power. That's it. Okay. So the utility infrastructure, generation, transmission, and distributions. Okay, there are independent system operators are there to take care ISOs to take care of the generations and industrial, commercial, and residual. These are the end user infrastructure. Okay, so the load follow the generation with intelligent grid. If you are saying it's a microgrid, the load will follow the grid, follow the generation, and something goes wrong automatically. It will trip some of the unimportant things. So the key technologies in smart grid, integrated communications are possible, fast and reliable communications of the grid, allowing the grid for real-time control, information and data exchange to optimize system reliability, asset utilization and security. Can be wireless power line or fiber optics which is used for this communication, okay, not for power transmission. So for wireless, Zigbee, WiMAX, Wi-Fi technologies are used. Okay, so here you can see here the broadband over power lines provide for two-way communications, monitor and smart relays at substations, monitors at transformers, circuit breakers, and reclosers, bi-directional meters, that is called net meter, I just now mentioned with two-way communications. These are things which are required. Okay. So here, the sensing and measurement. Sensing and the measurement means how to make the meter to be smart and how to fetch the data because data is important in a smart grid environment. So how to fetch all those information in the sense smart meter technology, real-time metering of congestion and grid stability. What is the congestion management? If some open circuit in a transmission line or open circuit in a particular transformer, generator outage. So all these things are called as congestion management. Okay. So using these congestion management, sometimes we are ensuring the grid stability. In equipment health, equipment health means whether everything is proper or not. Suppose, for example, if you take a transformer, always we have to monitor the transformer oil. Okay, where the transformer oil based on the moisture content, the lifetime of the transformer oil is varying. Okay, if you go and test some gas analyzing analyzer there, by seeing the gas formation in the oil itself, we can able to find what type of fault is there or which is the component which is getting deteriorated, etc. We can able to find it. Then energy theft. So important thing is, as I mentioned, 20% of the loss in the transmission line is going for energy, it is including your loss going for energy theft. So that is possible to reduce. Real-time thermal rate. See, there are some meters which is available. If you just pass it over the meter, motors, etc., it will show what is the temperature at various portion. Okay, and also sometimes it will show in different colors also. If the thermal rating is more, there it will be showing in terms of the image is in terms of red color, so like that. Okay, and the third, the last one is the real time pricing. That is also one of the technology once in the smart grid is coming. I can compete in the market and I can able to choose the tariff. How much load is load, how much of bulk load is required, how much is at what price you need and what time you require. So those things you can able to find it. Sir. The next device is of smart meter. So smart meters are your nothing but your energy meter only we are talking about. Okay, from there are some sensors from the center point. We can able to fetch the data. So the next one is about the phasor measurement units. So what is this phasor measurement units in the sense PMUs? These are all called PMUs. So this is a little costly when compared to other measuring units. That's why there are limited place only we can able to keep the phasor measurement units. Even there is a separate research to find what is the optimum place where you can able to keep the PMUs because of its cost. So real-time monitor of power quality, it will display your voltage, current flow, what's a real power, reactive power, etc. Okay. Sorry. So use GPS as a reference for precise measurement. Use GPS as a reference for precise measurement. That means using this global position system, we can able to identify where there is a fault. Suppose if there is a corona formation in a particular transmission line, I hope everyone know what is corona. Okay, there is a violet glow, which a ring which is formed, which will produce ozone gas and it corrode the transmission line. So those things can be able to find it. And nowadays, if you take our TNEB, now only they are doing the GIS. There is a separate AD there for GIS, Global Information System, where they will be taking the location of the transformer, transmission line, substation with the global, the satellite picture, and then they are recording. Okay, and where is the service? Where are the how many industries are there? Even how many transformers now only they are taking and then updating in the system. Then advanced components like flexible AC transfers. Already we have studied about. See earlier in the existing transmission line, in the existing conventional transmission line, we have fax devices. We have implemented this flexible AC transmission device where we are adding the inductors, capacitors to smoothen the voltage. Okay. So at some instant of time, your receiving end voltage is more than the sending end voltage. Any idea why? Those one belongs to triple E. Sometime the receiving end voltage is more than the sending end. What's the reason for that? That is because of Faraday effect. Okay? Faraday effect where the receiving end voltage is more than the sending end voltage. Okay. So here fax devices is one, then HVDC. So in some places wherever possible we'll go for HVDC transmission, not distribution. That is one thing. And so wherever the transmission line we are using only ACSR conductors, there by using these fiber optics or superconducting wire where the resistance is less, we can able to reduce the losses. In high temperature superconducting cables can be used. Distributed energy generation and storage devices wherever possible we are generating, not only generating, we can able to store it using a separate battery bank. So nowadays we are talking about all electric vehicle. So there in a smart grid also there is a good possibility where we can put yes a plug-in electric vehicle where it will act as whenever it is not in use, it will act as the battery bank for charging and discharging. In composite conductors and intelligent appliances. All the appliances is not only smart, it should be intelligent. That means self-healing property should be there. And power system automation is another key technologies in the smart grid where rapid diagnosis and precise solution to specific grid disruptions or outages, distributed intelligent agent, analytical tools involving software algorithms and high-speed computers are used in these automations and operational applications. And the distribution solution, the distribution side, if you are saying about the smart grid, what are the various things we can able to incorporate in the sense? As I mentioned earlier, we can do demand side management. This is shortly called DSM and demand response management. So that means whenever the power availability, what we are doing is whenever the peak load occur, we analyze the load curve. Whenever the load is more during that time, what we are doing during that time we are shifting the load. Wherever the cost is less, we are shifting. That's why it's called as demand side management. Okay. So most of the HT industries they will be getting the power even less than 1 rupee per unit during late night, maybe after 2 a.m., 3 a.m. like that. So during that time, if you are purchasing the power, okay, so the total operational power and operation cost will be reduced, and that's why it is called as demand side management. And next one is demand response. That is also similar to demand side management only. And smart buildings. So what is the smart building mean? So if the entire building there itself we are rooftop generation. See, there are some. See, recently in BIT we have a solar cell. From there, through government, a DST project was implemented in a particular building in Karnataka, where the complete building, light, fan, everything is operated with solar PV cells. Okay, so that is called a smart building. And once if you enter into the room, automatically the lights are on, and once if you are coming out, it will be off. So using these sensors, we can able to make not only a smart home, the entire building is going to be smart. So a little bit more about your demand side management. What is this? This is one area where you can able to do research. Those who are doing research in this smart grid environment, we can try for demand side management. So what is this demand side management mean? You can see that. So morning 5 a.m. to next day 5 a.m. So the different loads, um, the different loading pattern and energy consumption patterns are given here. So there we can able to see wherever there is a peak load, we can able to flatten it by fitting the curve the next area. That's why it's called as peak clipping, clamping. Those technologies are used in the demand side management also. Okay. So what is a logo behind that? If you can't use less energy, use it at different time. That's it, sir. So I can't able to reduce my consumption. I have to use it, but use it at different time. Different time in the sense whenever your energy bill is less, that time you can use it. Okay, that's all. So to do this demand response, this is shortly called as DR. So the purpose of doing this is to reduce the demand, peak load shifting. Whenever the load is at peak time, your tariff is also peak. You have to shift the load to some other place. Okay, so it's called fitting technology. Then improved asset utilization. So what is asset utilization in the sense? If you have a thermal power plant, you have a nuclear power plant means as much as possible you have to utilize it fully. Okay, and reduce the spinning reserve. See, there are some reserves. If it is a hydro station or thermal station, there are some stands, generators or transformers, as I mentioned, which is used as standby. So you have to reduce that. If you keep it as standby, most of the time we are not using that. So that's why whatever the thing which you are going for, it may be a transformer or it may be a generator, we have to plan to utilize fully. So the motivation and criteria of DR, the load response, direct load control is possible, curtailable load, interruptible load, these are the reliable to ensure the reliability, and there is load response and price response, critical peak pricing. So avoid this critical peak pricing, demand bidding, we have to do it. Okay, then economic point of view, direct load control is possible. So okay, then curtailable load control is also possible. Sorry. So time of use pricing. There are different types of pricing scheme as I mentioned. One is called availability based pricing or availability based tariff ABT. Okay. So that is otherwise called time of use pricing. At what time you are using the particular component. Based on that your price will be different. So nowadays this concept is introduced in our traveling also, even in your train. So during peak time, the peak time is in festival season where the demand is more, they will increase the price. Okay, so the same concept is there in all utilities, all companies. Okay, so time of use pricing, critical peak pricing, real time pricing, and demand bidding. So these are the various way we can able to adapt to reduce the economics and demand response. So just now we have discussed about the smart building. So what is my smart building and what are the various components which is present, how much is the cost which is involved over there. Even we are measuring how much is we have a meters. We are monitoring the complete buildings in VIT, and also we are taking the carbon footage. Carbon footage means if you use the solar panel instead of using the grid power, this is the grid power which is supplied for a smart building. There are some rooftop solar panel PV cells are available, and wherever possible, we are fetching. There is a small wind generation. You can see that this we have. There is a small pumping plant. A micro turbine is available. So using wherever possible, we'll be extracting the power, and we are feeding to the building. Okay. So if you do in that way, two-way communication with utility is possible. Proactive energy management, smart consumption is possible. Energy resource with on-site generation asset, storage capacity for added flexibility, and active carbon management. So these are the things we can able to take care if you go for a smart building. So we are using sensors. We can able to monitor how much is the total load, how much is the total temperature, what is the possibility if I go for shifting my generation from wind to solar or solar to wind, how it is feasible or economic. So those kind of thing we can able to find it in a smart building. An essential requirement for a paradigm shift. So why we need to do it is huge investment and government support is required. These are the essential things is required. When we go for a traditional grid to smart, it is not a one-day process or monthly process, and not even a yearly process. In long term only we can able to take care of this, and then we can implement. So robust communication infrastructure is required. Accurate remote terminal units, that is called RTUs. Okay. So these remote terminal units are present even for SCADA also. Okay. That should be accurate, and it should be uh, what to say. It should be whatever thing which is giving the information. It should be correct. If it is not correct information, if there is no correct, suppose a circuit breaker is open circuit, your RTU may say that the circuit breaker is a closed condition, maybe due to lack of communication or whatever the reason. So that will lead to malfunction. Okay. Then storage devices like batteries and electric vehicles should be incorporated effectively. Smart metering device to communicate the load pattern of different consumers to the corresponding utilities. Okay. The features of the smart grid: reliability. The reliability should be ensured. Flexibility in network topology, efficiency, load adjustment or load balancing, peak curtailment. Peak curtailment is your demand side management. Valley filling means wherever there is a less load present, we can able to clip the load, and then we can able to accommodate at the valley filling wherever the load is very less. So that our aim is to flatten the load curve, flatten the load curve. So that is demand side. That is the concept is coming under demand side management. So far we have discussed about the traditional grid and smart grid. So maybe as a consumer, I can ask why I have to go for replacement. As a supplier or a utility company, they will also ask why I need to shift it. Okay. So we make a call when there is a power outage. When there is a power outage, means power shutdown means immediately nearby EB or lineman who is nearby we are asking, and then or otherwise the immediate next house we are asking generally. Okay. So, but in a smart grid, utility knows the power is out and usually restore it automatically. And what's the reason for that? Everything will be displayed. So difficult to manage high renewable energy penetration, easy to manage here, cannot manage DG safely, can manage DG safely. Around 20% of the TND losses are there in a traditional grid, less than 2%. Because to take care by measuring everything, we are adding all the what to say compensation devices, we can able to reduce the TND losses, transmission and distribution losses. And also the other reason for less than 2% is because of we are having the distributed generation where we are connecting to the grid itself. In that way, the transmission and distribution cost will be reduced more. So key issues which make the grid smarter: transmission optimization, demand side management, distribution optimization, and asset optimizations. Retrofit recording transmission line to achieve the smartness. So what are things we need to fit to make the transmission line, the current transmission line to be smarter in a sense? We need more PMUs. Already PMUs are there in our grid. More PMUs are required. Wide area monitoring system (WAMS) or WAPS is required in order to complete monitor the system security. Operation of fax devices to enhance the system quality and controllability. All the fax devices should be operating. It should be properly operating and should be remotely operating. And in the distribution system, that is about the transmission system. The distribution system to shift the paradigm shift. What are things which is required in the sense we need SCADA, which is effective SCADA, application of power electronics whenever required in order to achieve smoother control, islanding of distribution system whenever required during DG. Okay, islanding of distribution means whenever it is not required, we can able to isolate it and easily we can able to connect it from the main grid or during the uh, to isolate the faulty portion from the healthy portion also it's possible. So advantage of smart grid for countries like India. In our country, that means the developing country, what are the advantage, whether it is good for going for the smart grid. If you are thinking about that, mean there is a job creation. So for all multidisciplinary area, all the engineers, different discipline of engineers are required. So job creation, innovation is possible, lower cost, okay, high customer satisfaction. Even there are some research which is going on in a smart grid environment where how to, what are the measures to measure the customer satisfaction. So drawbacks, so privacy and security. So the data is available in the cloud. So suppose your last month bill, if people were required, they can fetch it. So those things are possible. Smart meters, if they are not robust, can be hacked easily. So that is the another drawback in smart grid. So nowadays the same thing is happening in digital also. In the banking sector, everywhere this hacking is there. So hackers and anti-social elements can hack the data and can make the complete grid, which may even result in serious blackouts. So if something goes wrong, if blackouts occur, it is difficult and take more time, more than the traditional grid restoration time if you go for a smart grid. So not very simple because the concept is highly multidisciplinary. That's why. So I should have, even though I am a triple engineer, I should have the knowledge of electronics engineering and communications. Not only that, as a IT part or computer science engineer, I need to understand the concept behind the outages. So that's all about the smart grid. As the part of the smart grid, we can say it is a microgrid. So another two topics we are going to discuss. One is related to microgrid. Other one is how the smart grid is helping for a rural development improvement. Okay. So in a microgrid is the current status and future, where it is a small grid which contains distributed generation. Okay, and load. Okay. A microgrid is connected to the utility grid at a single point called as point of common coupling because there are different renewable energies are available. Everything is generating its own voltage level, its own power level. So everything should be commonly coupled after converting, inverting, and then making it a proper voltage. It can operate either in grid connector or islanded mode. Both mode are possible. Islanding occurs once the microgrid is disconnected from the utility grid. In an islanded mode, the DG is connected to the microgrid supply its load. Okay. In an islanded mode means there is no power from the utility grid. All the generators are operating locally, so that the total generation is added to the total generation should match the local load. So benefits, it can improve the reliability of the power supply, possibly at lower cost. See, I own my own the thermal station. I have my own um, wind station. Okay, so the today's or the next day availability we can able to find or I can able to forecast it easily. So the technology can be effectively used for combined heat and power application. It reduces the transmission power loss, reduce the environmental impact. That is important, sir. Energy diversifications, so different scheme from different scheme we are getting the power. It can support network voltage, especially suitable for off-grid remote area application. That's why, as I mentioned, the introduction itself, this microgrid structure is mainly developed for remote area where accessing the electricity is very difficult, or erecting the transmission and distribution line is difficult. In those sectors, we have to go for this microgrid. So the research and scope in microgrid, which is presently in our country, Department of Energy and US program target to develop commercial scale microgrid system for capacity greater than 10 megawatt by 2020. This is the past data, see whatever thing which I am showing. So already we have reached this milestone. Okay, and the outage time record if the load is less than 2%, the cost comparison of non-integrated baseline solution, emission reduction at least 20%, improving system energy more than 20%. Okay, the corresponding link, the citation also given there. So microgrid installation summary, you can see there is a bulk generation, transmission, it is connected to the market, and transmission is coming to there is bulk consumer is directly given, that means during wheeling, and distribution control, the municipal microgrid, the military microgrid, campus microgrid, commercial park microgrid, etc. So these microgrids are interconnected, and also you can able to operate in isolated mode also. So types of DC distributed generators are should be non-dispatchable. The maximum available power is harnessed in the maximum power point tracking method. So both PV and wind turbines are used. Dispatchable power output means your diesel, fuel cell, micro turbine, battery energy storage, or BS are the dispatchable power output. Okay. So these are some of the DGs which is there in practice. Here wind turbine, you can see here. Okay, micro turbines, fuel cells, solar panels are there. So I think all of you know what is the which is the maximum. We have a maximum solar panel generation in our state. Where it present? Any ideas? Sir? Around 648 megawatt of solar power generation we have from Adani Group. Okay, in south part of our country we are having it. So where you just go to Google it and then see what are the various features which is present in that 648 megawatt microgrid. It's not a microgrid. They are generating solar using solar power, and then they are even connecting their power to the grid, your traditional grid itself, and your DG, that is diesel generator, also one type of renewable energy only, and battery operated systems. So these are the various types of DGs which is available. And smart microgrid is to cope up with the future demand of power distribution grid. Both power electronics technology and their coordinated control based on the different method communication infrastructures are required. Eventually, these microgrid will evolve into form of microgrid clusters. At present, such systems are feasible only in rural areas where the power supply is limited. That's why this microgrid, forget about the smart world, only this microgrid is presently, even there are some villages where uh, we won't get power. Okay, still it is there. So that's the reason that once again from solar cell, uh, some 5 years back, once in the same Karnataka only, the remote place where around more than 100 houses are electrified using solar panel. Okay, that is one project. So hybrid microgrid cluster. So here there are various microgrids are there. It may be operating with isolated mode as well as combined mode. So whenever it is required, you can able to combine it. With the nearby microgrids, we can able to combine, and then our exchange highway, we can able to connect a grid where from that place we can able to connect to the substation directly and then connect it to the distribution network. So that these things are avoided. Your generation transmissions are avoided. Directly the power is given to the substation at 11 kV or 20 kV level. Okay. So the microgrid cluster will join together by a power exchange highway. In this, the isolators are power electronics converter that connect or isolate the microgrid with the PEH, that is power exchange highway. The cluster will coexist with this existing power infrastructure for the time being. As sufficient number of distributed generators get connected, this will pave the way for clusters without the need of bulk transmission. So those are the advantage of hybrid microgrid structures. So you can see the microgrid connections. See, maybe these things are operating at see, this may generate AC, this may generate AC or DC. According to the diagram, both are generating AC, that is connected to a DC supply and connected to the capacitor bank. So like this, different technologies are there to connect various microgrids. So in a microgrid cluster, okay, there are plug and play DGs that is normally expected to supply its local demand. Plug and play in the sense like your plug-in vehicle, plug-in hybrid vehicle is also possible. Whenever there is a demand, if your battery banks are not operated, we can able to share your battery. In this event, the power transfer through the isolator will not be required. However, when a microgrid requires power due to shortfall in generation, it will be supplied by the microgrids that have generation access. Therefore, the isolator must be able to facilitate bi-directional power. The microgrid structure will do bi-directional. So these are some of the UG projects we can able to give to your students, where microgrid research and development are gaining momentum. The future of low or medium voltage distribution grid is in the microstructure. Okay. Then there are some possible to write a startup, a women project, less than 30 years women projects are possible in the microgrid structure with the help of DSTs. Okay. So this is about the overview about the smart grid. And coming back to, just a minute please. Is the slide is visible, Lakshmi?
Yes, sir, visible, sir. Now visible.
Yeah, yes. Sir. So the second part of the session is about the smart grid in rural development. Yeah, smart grid is there, grid structures are there. What are the advantage, drawback, everything we have discussed. How it is helpful for a rural development. See, as I mentioned earlier, in a rural development only we are coming across this microgrid. The development of solar panel, rooftop solar panel, the microgrid structure, small micro turbine, micro hydro turbines, small windmills. So all these less than 5 megawatt generation is particularly designed for hilly regions where we can't able to erect a transmission line, distribution lines, etc. Then, with those technologies are helpful, that small DGs will helpful to improve the voltage profile of a traditional grid. That is why this DG concept is coming to picture. So before that, we have only compensation with the help of capacitors and inductors like fax devices. Okay, using SER, we are switching on and switching off the operations, etc. Okay, so nowadays we are talking about the smart grid combined with the rural grid. So here we are going to discuss about rural smart grid. What are the challenges facing in a rural smart grid? The possible solutions, and what are the R&D works which is going on in our countries. So already we have discussed about the definition of smart grid. It is an electrical grid, which is the combination of IT as well as the communication sectors. Okay. So to improve the efficiency, reliability, economics, and sustainability, we are going for this smart grid. Okay. To also facilitate to switch the conventional energy to renewable energy in the particular grid. The major benefits are significant improvement in the energy efficiency of the electricity grid as well as in the traditional grid. With the rural smart grid, what is the rural smart grid in the sense? The rural smart grid will provide improved electric service reliability and better power quality to the end consumer. End consumer means particularly the rural consumers. So the increasing use of renewable generation. Wherever the possibility is there, you don't want to rely only on the grid, that is conventional grid. It is possible to operate fully with renewable power generation. Increase use of energy that is produced locally. Wherever locally we are having, even there are small places where from the using this photovoltaic component uh, we are generating, using this fuel cells we are generating, wind generation, micro turbines, small hydros. In northeast part of our country, there are abundant source of hydro sources are available. Okay, there are something called runoff river. Without constructing a dam, wherever the flow rate is more, we can able to extract the power. Okay, so like this. Then reducing overall energy consumption, reducing consumer electricity bill. On overall, how to reduce the energy bill. Okay. So there are two-way grid infrastructure is possible. So on here we have generation. See, we can see that we have generation. There are variable energy sources are available. Grid scale storage. So everything is connected to the grid and transmitted, distributed. So like that we are having. But now what we are going to do is that's a two-way communication. Okay. See the arrows. So now we are concentrate only on the distribution area where wherever possible. So already we have discussed about the microgrid structure we can able to do. Okay, demand response. So with the existing source itself. For example, we have solar generation between uh, maybe 8 a.m. to evening 5 p.m. So during that time, is it possible to shift your load? Some of the load we need only in nights. For example, AC load in the sense during sleeping only we need AC load. I can't even shift it. So those things I am not talking about. Whichever is possible to shift, there we can use it. Here, plug-in electric vehicle. Nowadays we are talking about electric vehicle, and the government is having developing some policies. Already developed some policies which are not feasible, and they are going for more flexibilities. And even on all petrol stations, they are erecting the now Indian Oil is coming into picture. They are having all charging stations, etc. So in all these charging stations, if some of the batteries are your own electric vehicle during night time, if you are not using your batteries, you can able to share your energy. Okay, so that's why the transport, distributed storage, energy efficiency, distributed energy resources. So those things are able to connect in the end user perspectives. So the aim of this smart grid is to eliminate this, not only communicating, in order to eliminate this portion, generation, transmission, etc. How to completely use this, and that is called as self-sustainability or self. The grid should be self-sustainable. Okay. So how to make that? That is why it is the purpose of this rural grid. Okay. So the main issues related to this is even though we are saying it's a microgrid, there are some limitation in the generation availability. There are some minimum that is there are some drawbacks in the technology improvement, even the plug-in electric vehicle what we are talking about. So these are the limitations of the microgrid or the rural development. Okay. So in the rural distributed station, as I mentioned earlier, these rooftop solar panels are developed particularly for the places where there is no electricity so far. Okay, so the challenges, development of appropriate design methodology. That's why I said. So we are there. We are having slowly. If we go to the literature, there are so many inverters, converters are there, technologies are there. So, but once if you come for the technology that is implementation, there are some places where we can able to improve our design. So development of new operation and planning security practice. Okay, so this is related to the strategies developed by the government, both state government and central government. Okay, planning strategies and security strategies are still lagging. Lack of knowledge in rural roads. Yes, so we don't know the load pattern of the rural. So if it is an industry, we know that how many shifts are there, what are the total connected load, etc. But rural load, it is difficult to understand. So accordingly, you can't able to plan it. See, sometime even if there is no load, the entire generation is waste. You can't able to store it. If it is a renewable energy based, we can't able to do that. So rural distribution network to simulate the model, we are lack of rural load data also. So forecasting of power system, short-term forecasting, short-term rural load forecasting is difficult because of lack of load only, lack of knowledge of load. Okay, we don't know the structure of that. Improvement on communication systems are required. See, already it is a rural we are saying their power itself. Now only we are doing. You think about the communication system. If the communication system is not proper, then the entire smart. We can't able to say that is a smart grid. So design of control strategies, design of new production scheme. So these are the things where we have to concentrate and what are the various challenges in the rural smart grid. So coming to our country, so what are the various things, effort put by government. There is one MNRE, Ministry of Non-Renewable Energy Sources. So where we can able to Ministry of Science and Technology also, where we can able to find there is one forum, ISGF, mostly it may be there in your college also, where Indian Smart Grid Forum, they have divided the work into different areas, the possible areas where we need to concentrate in 2017 itself. And from that onwards, it is keep on developing. So we have all these forums. So we can contribute your research in advanced transmission system, distribution system, in communication part. If you are developing some ideas, you can able to join the forum and you can share your ideas. You can register your pattern there. Okay, the metering system, how to develop the smart meters, the existing smart meter, what are the drawback. See, the main thing is about the cost, sir. If you are going to replace the complete digital meters, so rarely you will be finding some analog meters also. So if you want to replace completely, it should be with an affordable cost. Okay, so that is also there. Then consumption and load control remotely, regulation and policies. Okay, policy development, regulation development. There are some guidelines or IE rules should be developed. There are some standards, I can say that should be developed and that should be given as a concrete one to follow. In architecture and design, renewable and microgrids, cyber security. This is important, sir. What is the cyber security in the sense? Not only the banking sector, in the power grid also. If the cyber security, if it is not operated, there may be some malfunction, and that leads to blackouts and brownouts of the grid. Okay, that will entirely collapse the entire country economics once again. So many pilot projects are possible, and many business models are already there, and still development is going on in these rural environments. Okay, so research and development possibilities in smart grid. So operation, control, and protections as a faculty, what we can able to do. Okay, we can able to contribute as an electronics engineer. We can able to communication engineer. We can able to contribute. So for everyone, there is a scope, and you can operate as a transdisciplinary, not even multidisciplinary. Transdisciplinary also we can able to do it. Information and communication technology, cyber securities are the areas where we can able to contribute. Device and technologies. Once again, the core engineers, power electronics engineers also will be able to work. Will make it as a converter to be smart, your inverter to be smart, etc. So your distributed energy resource, storage, and deployment issues also possible. So this is just an overview about it. Before, if you want to start your research, there is a possibility to know about. As an electronics engineer, you need to know about what is grid, how many grids are there, where we can able to do it. In our country, we have five different grid: northern, eastern, western, and southern grid. Okay, so little knowledge is required for you if you want to work it in the smart grid environment. That's why I incorporated these things. So all these five grids are interconnected now, sir. So earlier, only the southern part is not interconnected. Nowadays, all these one nation, one grid we have. So even there is a small disturbance occur in south part of our country, that will affect your northern or northeastern part of the country. So everything is connected. Okay. So smart grid project implemented. These are some of the pilot project which is already present. So here, to nearby, if you see that in Puducherry, that is Pondicherry, there is a distribution automation is possible. Around all the distribution transformer which is present in Pondicherry, uh, that is taken, and then as a pilot project they have implemented, and they can able to monitor it. They can able to switch off and switch on the transformers. Okay, those things are there in this pilot project. So these are some of the innovative universities which is working already in smart grid. And as I mentioned earlier, VIT also contribute to the DST by implementing the microgrid in Karnataka in a rural area in the hilly zone. Then also there is a separate building recently they have implemented with a rooftop solar panel which is completely operated with uh, solar. So these are some of the bodies they are supporting our research. DST, SERB, okay, Ministry of Non-Renewable Energy Sources, Ministry of Power, okay, etc. So these are the labs in the area of interest, like CPRI, Central Power Research Institute, where there is a possibility to write our research proposal and there is a possibility to get the fund. And Delhi Energy and Research Institute, that is also supplied. CDAC is also ready to contribute. And there are some private people which is there, Tata Power, Bangalore Electricity Distribution Company, Reliance Power, Haryana Vidyut uh, Prasar Nigam Limited, Bombay Suburban Electricity. So these are some of the private sectors which is there in the distribution side. And this is to highlight, this is to show you some of the project which is already implemented to know where we can able to write a proposal as a factor. So the list is going on. Mostly, if you see in the DST side, many IITs they are getting. Okay, they are trusting the government institution. That is one reason. But nowadays there is a possibility for even a small engineering college also to get the projects. So that's all about the rural sector. So only to before going to conclude the session, I'll be showing our contribution towards the microgrid in our lab. Just a minute, please. Is it visible, ma'am? Mahalakshmi? The next slide, application of electric spring.
Yes, sir. Visible, sir.
Yeah, yes, ma'am. So application of electric spring in smart grid. So in order to contribute the smart grid, what we have thought is we introduce a concept for called electric spring, which is almost similar to your mechanical spring. How your spring is compressed mode, normal mode, and elastic mode. So these are the three ways which is incorporated in your mechanical spring. Okay. So the same thing we have take the analogy in the electric spring. In normal mode, your normal voltage is there at point of common coupling. So while discussing about the smart grid, I said that point of common coupling where we can able to connect all the possible source. So in that same place, we can able to erect this electric spring concept also. In compressed mode, your for a point of common coupling voltage is more than the normal voltage, and in elastic mode, your point of common coupling is less when compared to the normal voltage. So here the renewable energies, different right for renewable energies are there. You can incorporate storage device, and if you are implementing some type of other sources, you can add it and connect to the point of common coupling. And this electric spring will be connected in series with your non-critical load, and there is something called critical. I'll tell you the difference between critical and non-critical load. Critical loads are load where I can't able to reduce the voltage. So if all the power, renewable energy, or power storage, everything, if it is giving 230 volt, then only I can able to operate this load. That is called critical load. But there are some load called non-critical load. But even if the load is less than 200, maybe 180 volt, I can able to operate it. Instead of switching off the complete load, we can able to operate with 50% load. That's the idea, sir. So that's why we are incorporating this electric spring in series with your non-critical load. And here you can see that while operating it, okay, the 220, see the nominal system voltage is 220 volt we have considered, and the various resistance for the critical and non-critical load are considered. Okay, so the battery capacity and how much is the power which we have considered. Okay, and see the critical load voltage is this. Sorry, not yeah, the critical voltage is this, and the non-critical voltage is 180 volt. Even with this load itself, we can able to operate the remaining equipment. So by doing that, we can able to save the 15% of the real power. Okay, reduction the real power. That means even the power is reduced by 50%, we can able to operate the existing system. So to incorporate the electric spring, we have formed the small microgrid in our lab, power system research lab itself. You can see here there is a main grid. Okay, there are some distribution lines which are available, and see critical load as well as non-critical load with electric springs are incorporated in bus number 3. Okay, so your renewable generator is feeding bus number 2, and renewable generator is also filled to bus number 4. Okay, there is additionally the same setup of critical non-critical load with ES is electric spring is connected to the first grid also. So in that way, instead of cutting the instead of going for load shedding, if the renewable energy is not available, instead of taking from the microgrid, okay, so using this electric spring and non-critical load setup, we can able to operate the node. Okay. So by doing that, so I'll show you the final. Yeah, there are some proposed energy management system also we have done. So by doing that, what we can do is the total power consumption is reduced, even though your generation is reduced. So that's the idea behind it. And the total power consumption also plotted. I'll share the slides. You can just go through that. And the literature, in the literature also, all our contributions related to electric spring is also available. So this is one of the device which is used for improving your voltage profile, particularly in the non-critical environment. Just I thought to share you. This is related to the subject, related to smart grid. That's why I'm thinking to share you. Different environment, different cases we have considered. We have considered 5 different cases. Each and every case, the combination of renewable generators, microgrid structures, the voltage level of that is different. That's it. Okay, so that you can see here, each and every case we are saying that how where the fluctuation is. That fluctuation means we purposely sorry at the second the sense the simulation is for 100 second. In the second to 96 second we are making the voltage profile, we dip the voltage. Okay, so that how the corresponding system will take care the load non-critical. So like that we have done, and how much is the real power and reactive power consumption also we have discussed. Yes. So thank you all for your attention. So far, I just within 2 minutes time, I can brief you. We have started with the traditional grid, and then how the smart grid is different from the existing traditional grid, and how what are the various challenges present in a generalized smart grid, and if you go towards the rural grid, in that case, is it possible to connect your smart grid with the rural grid, and how the microgrid structures are different from a smart grid. Okay, and the implication of the electric spring in the smart grid, how it will improve the voltage profile and power consumption. So these are the things which I have shared. Because of wandering of time, I will be stopping at this time, and thank you for your attention.
Thank you, sir. The
Yeah.
session was really interesting and informative, sir. Hope our participant would gain information from this session. It was very clear about smart grid with rural development, sir.
Yeah.
Thank you for
So any
spending your valuable time with us, sir. Kindly accept a virtual memento, sir.
so any question from audience also you can feel free to ask, or in future if you have any thinking to collaborate, we'll collaborate and then we'll work.
Mahalashmi.
Hello, sir.
Mahalashmi, share the momentum.
Yes, ma'am. Yes,
Sorry for
yes.
the inconvenience, sir, due
No
to
issue.
some
No
network
issue.
issues, sir.
Okay, ma'am. Okay. Yeah, Anthony sir, shall we conclude the session?
Yeah. Is the screen visible, sir?
Yeah, it's visible. Yeah.
Thank
Thank
you,
you,
sir.
ma'am.
Thank
Yeah,
you
thank
for
you. Thank you. Yeah,
accepting our
thank you. Thank you.
invitation, sir.
Thank you, ma'am. Thank you.
Thank you, sir. Thank you for giving a wonderful
Thank
session, sir.
Vote of thanks. I, on behalf of JPR Institute of Technology, and I own behalf extend a very hearty thanks to our director, Sir Dr. Mary Wilson, and our principal one, Dr. L. Merlin Livingston, for providing encouragement and support to organize the event. I would like to thank our chief guest, Dr. B. Saravanan sir, for enlightening us with their knowledge. Today's faculty development program was full of knowledge and information. I request the participant to fill the feedback form which is posted in the chat box to get e certificates. At last, I would like to thank the entire crew of the event. Thank you all.